Hey there, folks. It's still Wednesday the 16th. You probably have watched the Interlude B video first and then are watching this one. So this is all part of the same lecture, but I broke it up into two parts since there's two parts in the book. So in this particular section, we're looking at sedimentary rocks. So remember we talked about the rock cycle, and we said the rock cycle worked because of plate tectonics, and we can identify three major groups of rocks. We looked at igneous rocks. Those are rocks, of course, that were at one time molten and have solidified or frozen into rock. Now we're going to look at sedimentary rock, which is rock that is formed through sediments. And then finally, in the next lecture, we'll look at metamorphic rocks that have changed. So sedimentary rocks, just in their name, tells us kind of how they were formed. They were formed from sediments. And like I said, usually in class, I bring in a bunch of rocks, and so it's going to be kind of hard for me to show to you. Sedimentary rocks really aren't as cool as some of the metamorphic rocks and igneous rocks in terms of what they look like, because we see them all the time. They're probably the most common, especially around here in Kentucky, because we live on top of limestone, which is a sedimentary rock. And so just driving down the highway, you see those road cuts, and you see all those different layers of rock in the road cut. Well, those are sedimentary rocks, and those are the sediments. That's how it's been laid down. We'll talk about that in more detail here in just a minute. But let me show you a few different rocks. So here is a piece of limestone. And like I said, it's not very pretty. It's just kind of an old gray rock. But one of the cool things about sedimentary rocks is the fact that you can have fossils. And so there are some fossils in this particular sedimentary rock. The limestone then was formed from animals who had their shells crushed and formed this kind of a rock. And so this whole area, Kentucky, Indiana, all this area, was at one time a very large, shallow sea, and had just tons and tons of organisms that we can see. And I'll do a video at some point down on the Falls of the Ohio. If you've never gotten a chance to go over there, go over the bridge and look at the Falls of the Ohio over in Indiana, and you can see all those amazing fossils over there. And if you get a chance, go in the museum and look at some of that there. But definitely go out on the beds. You need to pick a time when it hasn't rained in a while, because the water will be lower and you can get out more on the beds. But there you can see the limestone and some of those fossils. So those are fossils that were onto limestone crushed organisms. But here's one where you can see the organisms didn't really get crushed. So there we have fossilized shells of bivalves and clams and mollusks, that sort of thing, that we might see today. And so there's an example of a sedimentary rock where literally the pieces of shell kind of got cemented together. This one's kind of interesting because literally you're looking at the bottom of a sea, bottom of an ocean. In other words, what happened was this was where things collected at the bottom of a sea, and then something happened, and a lot of sediment came and kind of preserved all this. And so, literally, what's kind of cool about this rock is a couple 100 million years ago, if you'd gone scuba snorkeling, this is what you would have seen on the bottom, and it got covered up and eventually turned into rock. And so there you can actually see some of the shells and things that are part of that. Now, some of the most pretty ones we'll see are the chemical sedimentary rocks. So here's a piece of agate that where you can actually see the different layers, how they've been built up chemically, right? And then finally a layer on the inside that gets turned into, there you can see crystals and stuff got turned into the minerals, and the crystals were allowed to grow. But out here, we just had secretion of layers, right, of a chemical sedimentary rock. So this is all mineral, but at the same time, it's laid down like a sedimentary rock. The only other one I got is a piece of mudstone, and it just looks like mud. I mean, it looks literally like This would be a pile of mud that just recently you scraped off your shoe, and you can even see it sort of looks almost like it's still got water in it. But this mud was formed millions of years ago, and now has solidified into mudstone or a rock. Probably one of the ones that we think of the most in terms of organic sedimentary rocks are coal. And there's a piece of coal. And we're going to learn that coal is made purely from the carbon of organisms like trees and plants and animals. And because it is carbon, we could take this and I could actually set this rock on fire. I could actually burn this rock. And so we burn coal for electricity, and we now know it's pretty dirty. But this is a piece of coal that we think of, and especially around here in eastern Kentucky, of organic sedimentary rocks. So, again, I apologize that I can't be there in person and let you touch and feel the rocks, and I bring in a lot more. But sedimentary rocks really are much more fun if you see them in their environment. In other words, you're driving down the road and you see a road cut. You're not on the interstate, but you're on somewhere where you could pull off and actually get over and look at the road cut. It's really fascinating. Not just from the standpoint of the layers, right? But what fascinates me is in between the layers. In other words, you've got this layer of gray stuff, and on top of it, a layer of darker stuff. Well, what happened right there, right? What happened to cause this change? And that's one of the things we're going to look at, is that sedimentary rocks are really great because they teach us about the organisms that lived millions of years ago, and they teach us a lot about the environment. I mean, was it a desert? Was it an ocean? Was it a lake? Was it a river? And so just from sedimentary rocks and where they are and how they formed can teach us a whole bunch about what the Earth was like millions of years before there were people, or certainly geologists. So let's jump into the chapter. This is chapter, what is this, chapter 6? I'm not even sure. Let's see here. Chapter 7, sorry. So this is chapter 7, where we're looking at sedimentary rocks. And there you see some rocks. Again, you can see all the different layers and different types of rocks that you might see. I think this one's in Nevada. But you can see them here too, just from the way we've made our highways. So sedimentary rocks have many classes, as you can imagine. So we're going to look at 4 different classes of sedimentary rocks. First class is called the clastic sedimentary rocks, and clastic simply means glued, cemented together. That's all clastic means. So when you see the word clastic, and you'll see it quite a bit in your reading, it simply means cemented together. So you literally got little pieces of sand, right, or whatever, and they're literally cemented together by evaporation of water or whatever, some chemical means possibly. But it's just kind of a natural cement that has put these rocks together. The second one are biochemical sedimentary rocks. And again, this is where we live. We live on limestone, and limestone is probably the most prolific biochemical sedimentary rock. Limestone is literally the shells of organisms. And so here in Kentucky, you can go down hundreds of feet into limestone, which just tells us that for millions and millions and millions and millions of years, literally billions and trillions of organisms lived here and died, and their shells now make up the rock that we walk on, which is pretty amazing. Organic sedimentary rock, and of course we've talked about coal, is probably the most obvious one of those. And then finally chemical sedimentary rocks, like the piece of agate that I showed you. Those, we don't see a lot of those around here, but they do exist. So we've got all 4 of the different types of sedimentary rock that are here. So let's start looking at them. Specifically, let's look at the clastic rocks. And again, probably one of the most obvious of those is sandstone. It's called sandstone because it's literally made of sand. So these are sand particles. These are little pieces of rock that have weathered off of larger rock, have been eroded away, and have been moved somewhere, usually maybe downwind or down a river into a lower area. And then eventually that sediment will collect And as it collects over time, the force, the weight of more and more and more sediment literally presses the water out of the sediment and forces it into a clastic, a cemented together sedimentary rock. So there we can see the whole process, right? And that's kind of important that we understand how that works, right? If you've been to the Grand Canyon, you've kind of seen this process or seen the result of the process where you have these rocks that have been deposited over, excuse me, been deposited over literally millions of years and formed into a classic sedimentary rock like sandstone. And here is a really neat place. I got a chance to go to Mesa Verde when I was out west. This is an amazing area where this entire group of people basically built a city underneath this sandstone overhang. Now it's an overhang, right? Because the rocks above it are stronger than the rocks below it. So the water kind of cut this hole back in this rock. And so these people literally built entire villages and towns out of these rocks. When we look at sedimentary rocks, classic sedimentary rocks, we look at the particle sizes, right? So you might have a sedimentary rock where the particle sizes are really big, and that tells you they didn't weather all that much, right? You may have particle sizes where particles where they're all different kinds of particles. You might have a little bit of this, a little bit of that, and so you get kind of a variety of particles. That would tell you something about the environment in which it was made. You might see the difference between rocks that are sharp, angular, and haven't eroded much, and rocks that are more spherical, rocks that are kind of like round marbles that have eroded quite a bit. So they're round because they were moved through wind or water over a longer period, longer distance, right? And eroded and weathered off more and more of it. And so that would give you an idea of where that rock formed and its environment. Very important because this would make a really great test question. Talking about looking at a rock and seeing how it was sorted or seeing how the sediments are shaped would give you some clue as to where that rock came from and how it was formed, right? Make a good test question. So again, the sorting we looked at, as you can imagine, as rocks move down a river, right, the heavier rocks would fall out first. By the time you got to the end of the river or near the end of the river, all you'd have left are the really small rocks, the really rocks at a very small size. So if you had a rock that had particles in it that were all different sizes, that would let you know it probably didn't erode very far, did it? But if you have a rock where all the particles are the same size, it kind of lets you know that rock was formed where we had quite a bit of movement and rocks were able to sort out a little bit more. Origin of these rocks, we don't worry too much about, but again, the differences between something like a breccia, where the particles are kind of sharp, have sharp angular edges, and conglomerates, where they're more rounded, would give you a clue as to what caused that rock to be formed. They talk about siltstone and shale and some mudstone. We have a lot of shale around here. We have a lot of siltstone, and I showed you some mudstone. And so these are rocks that have very fine particles. I mean, very, very fine particles. If you look at the Ohio River right now, you notice it's not clear, is it? It's kind of muddy looking because all those big particles, right, from the creeks and the rivers that feed into the Ohio River, all those big rocks and stuff, they're still in the creek and they're still in the river. The only thing that makes it to the Ohio, right, is the really small stuff, literally the mud. And so the Ohio River looks kind of muddy because that's all that made it in terms of sediment to the Ohio River. And so a creek or a smaller river might have more clear water, right? But as it gets to the Ohio, the only thing left is kind of the mud, and that's why the Ohio and the Mississippi and Missouri and big rivers like that all look real muddy. All right, so biochemical sedimentary rocks. Again, we live in a world of limestone here in Kentucky. Uh, so we have lots of caves. We have lots of areas where the limestone has eroded away because the water that rains is slightly acidic, and therefore it literally dissolves the limestone. And so we get places where the water has eroded away, has dissolved the limestone, and that's what we see in an area like here. Oops, sorry about that. Go back up. Wow, I jumped too far, didn't I? Sorry. Let me get back to where I was. I changed chapters on you. Apologize for that. So anyway, the next group of rocks then are the, well, let's go up here and see what they are. I think that's where we were. Yeah, you hit the wrong button around here and you're in trouble, aren't you? Are the organic sedimentary rocks, and we've talked a little bit about that in terms of coal. So if you've ever seen coal, if you lived 100 years ago, you saw lots of coal because you'd go out and buy it and use it to heat your house. But again, this is a sedimentary rock that's made from organic things like plants and animals. We're all made as living organisms. All of our organic molecules have carbon as the base. We call it the carbon chain of molecules. And so all the other things like oxygen and hydrogen and all those other chemicals can erode away. The only thing that gets left then is the carbon. And so when we dig up coal, we're literally digging up what's left of maybe a forest or a dinosaur or some other plant or animal. And so that's where our coal comes from. And again, these are sedimentary rocks that were at one time organic. Then we have chemical sedimentary rocks, and again, they are made just purely of chemicals. We've seen that the chemical will land in the chemical basically is suspended in water. You can imagine salt. If you took some water with a bunch of salt in it and began to evaporate the water, eventually you'd get a sedimentary rock, a chemical sedimentary rock of pure salt. And so these are what we call evaporites because, again, they're suspended in water, and as the water evaporates, it leaves the chemical behind, and that can make a rock. And there's some that we just looked at of these kinds of rocks. There's a piece of that agate I just showed you. There you can see, you saw the growth rings. Oops. Dang, I tell you, this jumps around on me, sorry. A piece of that agate. I'll figure this out eventually, guys, don't worry. A piece of this agate that I showed you. Now let's look at what they call sedimentary structures. That's why I said a lot of times it's a lot neater to go out and look at a big rock cut or a road cut rather, and look at all the different sedimentary layers because that's where the stories are. I mean, that's where it tells you there was a flood here 20 million years ago, and then 15 million years ago there was a sea here, and you can see all the animals that used to live here, and then after that all the water dried up and there was a desert. And you can tell all that by just looking at the structures and reading the different types of rocks that exist in these structures. This is called bedding and stratification. So the bedding is just literally what you think of as a bed, something flat. Now, of course, some of this flat bedding, right, over time has gotten affected by plate tectonics, and some of it can get it's not flat anymore, is it? It's kind of at an angle. So you can drive in through some of the mountains and see these things that look like beta and strata, and they're kind of at a 45-degree angle. That's because they were at one time flat and were formed flat, right? Because the water is perfectly flat. And then all of a sudden you see them at an angle. They got pushed up millions of years after they were formed. We can also see in these environments ripple marks. So if you saw ripple marks in a particular sedimentary rock, that would kind of let you know it was near an ocean. You might see dune marks. In other words, the bedding is not nice and flat, but it's all looks like a sand dune. And so this could be rock that was formed in a dry environment rather than a watery environment. And there's some really neat stuff out west. I think there's some pictures in here that you can see that'll show you that kind of bedding. We can look at the beds of old rivers and old creeks. We can see what's left of them. Yeah, here's a picture of like sand dunes. And so you can go out west and places where it's still a desert. It was a desert before. And you can see these dune areas, these ripple marks where the sand dune, there's an example of that. And there's some rock that you might see out west, a rock cut that looks very different than what you might see here where we had an ocean and a sea that created these perfectly flat beds of rock. Then this next section is all about how we use rocks to recognize these environments. And so if you know what you're looking for, you can look at these rocks and literally tell the story about what happened in this area. And if you know the dates, and again, sedimentary rocks, of course, are made of rocks of all different kinds of dates. So we want to know when those sediments sort of became a rock. And a lot of times we use fossils to do that. And we'll talk about that in a little bit more detail when we talk about fossils. But here we can even see mudstone and places where, when mud dries out, it begins to crack. If that gets preserved in a rock, you can actually see that cracking that happened in the rock millions of years ago. Here you see bedding and you see erosion that's happened. Obviously, the rock that's gone, that's missing, you can see the kind of the piles of it down here. This is all the sediment and stuff from rock that's been eroded away. These rocks are harder, aren't they? These rocks are made of a harder material. That's why they're still there. They will eventually erode away too, but the first thing that erodes away is the soft material, and here's all that soft rock. But then you have the harder rock here that remains. And that kind of gives you a clue too about what these particular rocks are made of. Here's the big map again, the big pictures that show you so much of, helps you so much understand what we just went over. So please make sure you get these in your notes as to what things are. It goes through some different environments, and so definitely read this. Again, looking at, if you know what the sediments are and you know what you're looking for, you can tell the difference between a desert environment, a glacial environment, how glaciers moved through, what river environments were there. Again, you can tell this by just looking at the sediments, right? If the sediments are well worn, you know that they've been in a river environment. If the sediments are angular and kind of sharp, you know they didn't get to a river. They might have been more in a desert or even higher up in like a mountain kind of environment, like a mountain stream environment, right? And that would also make a great test question to ask you about rocks. Have you look at the sediments and see if you can tell what sort of environments they may have come from. Oops. We live in an area where there was a lot of this shallow water, kind of a shallow sea. And so we see a lot of these deposits of marine organisms, and that's where the limestone comes from. You can go out to these creeks and rivers almost anywhere in Kentucky and find these amazing fossils of organisms that used to live here millions of years ago, 200 and 300 million years ago, that lived in this shallow sea that was here. Since that time, Kentucky's been kind of uplifted. The sea has retreated, and what's left then are the organisms, again, that used to live here. And so, again, it's a neat little story that you can tell just by looking at what is here. You'll see sedimentary basins, places where the rock has, it's doing that. There we go, make it stop. And you can see the different organisms that live. And again, we'll get into that in more detail when we get to looking at, boy, guys, I'm having a real problem controlling this silly thing. I'll figure this out one of these days. Anyway, I just jumped way up ahead and I didn't mean to. So let me get back down where we were. Sorry, I'm wasting your time. But anyway, this is what's kind of neat about, again, living here in Kentucky, is to be able to go out and find a place where the rock has been cut away And you can, and if you again know what these rocks are, and there's ways of telling, which we'll get into more detail, you can kind of tell what sort of environments and what was happening at the time. Again, we were talking about sedimentary basins and the fact that these are places where water will come in with sediment in it, and the sediment will settle and eventually become rock. And we can learn a lot about what's happened in the past based on what that rock is and what it looks like. All right, so that is sedimentary rocks. And again, I apologize that the pictures I have of them aren't that pretty. And even when I pass them around in class, they're not that impressive unless you're looking at fossils. But they are much more impressive if you go out and actually find some of these road cuts and actually kind of get in there and dig around a little bit and look at the rocks. And especially if you do that, look at where these layers come together, because that what happened right there is the cataclysm, some cataclysmic event. This thing was perfectly fine as an ocean, then all of a sudden something cataclysmic happened, all the water drained away, and something else happened. So from that standpoint, sedimentary rocks are kind of cool. All right, here's your questions that you can answer. Review questions. Pick 5 of those if you wish, and turn those in to me. And very soon we will talk about our third type of rock, metamorphic rock, in our next lecture.